Good evening, students. Now I am here for the problem solving, and that is of the topic that is communication system. So in this lecture, we will solve some more questions on the communication system. AM is used for broadcasting because AM amplitude modulation is used for broadcasting because first option, it is more noise immune than it is more noise immune than other modulation systems. Other modulation systems. Second option, it requires it requires it requires less transmitting energy less transmitting energy, or you can say transmitting power compared with other system, compared with other systems. Third option, its use avoids receiver complexity. Its use avoids receiver complexity. No other modulation systems can provide bandwidth faithful transmission, right? So it is saying that AM is used for what is the reason among these four. First option, they have given that it is more noise immune than other modulation systems. That is wrong. It requires less transmitting power compared with other systems. So this is also wrong. Its used avoids receiver complexity. So this is the correct option. So AM is used because its use avoids the receiver complexity, right? Next question. Range of frequencies allotted for commercial FM radio broadcast is. So range of frequencies allotted for commercial FM radio broadcast is first option 88 to 108 megahertz, second 88 to 108 kilohertz, third 8 to 88 megahertz, and fourth option 88 to 108 gigahertz. So range of frequencies that is allotted for commercial FM radio is 88 to 108 megahertz. Third question, if mu1 and mu2 are the refractive indices of the materials of core and cladding of an optical fiber then the light due to its leakage can be minimized by having first mu1 is greater than mu2, second mu2 is less than mu1, third mu1 is equals to mu2, fourth option none, right? So if mu1 and mu2 are the refractive indices of the materials of core and cladding of an optical fiber, then the light due to its leakage can be minimized by, in that case mu1 should be greater than mu2, because if mu1 is greater than mu2, in that case there is a possibility of TIR, because the first condition for TIR is light should move from denser to rarer medium, right? So core is inside part and cladding is the outside part. So if light is moving from core to cladding, in that case it will encounter denser to rarer interference, then in that case there is a possibility of TIR, and if TIR is taking place, in that case complete light will come back into its own medium, the previous medium, so there will not be any loss of light leakage, right? Next question. The radio wave of frequencies from 300 megahertz to 3000 megahertz belongs to. So it is saying that the radio waves of frequency 300 megahertz to 3000 megahertz belongs to. So options are: first, high frequency band; Second, very high frequency band. Third, ultra high frequency band. Ultra high frequency band. Fourth option, super high frequency band, right? So the radio wave of frequency from 300 megahertz to 3000 megahertz belongs to ultra high frequency band. Next, the maximum peak to peak voltage. The maximum peak to peak voltage of an AM wire is 24 millivolt, and the minimum peak to peak voltage. The minimum peak to peak voltage is 8 millivolt. Then modulation factor is right. Then the modulation factor is first option 10%, second option 20%, third option 25%, and fourth option 50%. Over here, Vmax is given as 24 by 2, that is 12 millivolt, and V minimum is given as 8 by 2, that is 4 millivolt, right? So what is modulation factor? M. Modulation factor is Vmax minus V minimum divided by Vmax plus V minimum into 100, right? So Vmax is 12, so it is 12 minus 4 divided by 12 plus 4, so that is 8 by 16 into 100. So it comes out as 50%. So modulation factor is given as 50%. Next question. If a number of sine waves sine wave with modulation indices N1, N2, N3, modulate a carrier wave then total modulation index of the wave is. So first option, it is under root of n1 plus n2 plus 2 n1 plus second n1 minus n2 plus n3 minus n4 n1 square plus n2 square n3 square. Fourth option, none, right? So in this case, the total modulation index is given by this third option. Next, if an AM wave has an AM wave has 1800 watt of total power content for 100% modulation, the carrier should have power content equals to so it is given as first option 1000 watt, second option is given as 1200 watt, third option 1500 watt, fourth option is 1600 watt. So here MA is 1, modulation factor is given as what here 1, so that implies PE is given as 1800, which implies power of the carrier wave should have power content 1200 watt. This is power content of carrier wave. That is 1200 watt. A TV tower has a height of 75 meter. So height of TV tower is 75 meter. What is the maximum distance and area? What is the maximum distance and area up to which this TV transmission can be received right? Take the radius of Earth as 6.4 into 10 raised to the power 6 meter. What is the maximum distance and area up to which this TV transmission can be received, right? So the distance we can write as under root of 2 and into height of tower. 2 into R is 6.4 into 10 raised to the power 6 into height is 75 meter, that is 64 into 75 into 10 raised to the power 6. So it comes out as 8 into 5 into root 2 into 10 raised to the power 3. So that is approximately equals to 31 kilometers, right? So the transmission can be done up to a diameter, up to a radius of 31 kilometers. So area covered is pi into d square. D is 31 whole square. So square of 31 is, it will give a value of 3018 kilometer square. So the transmission can be covered up to an area of 3018 kilometer square. Next question. What is the modulation index? What is the modulation index of an over modulated wave? What is the modulation index of over modulated wave? That is equals to 1, second less than 1, third greater than 1, 4, 0. So over means it is greater than 1. So what modulation index for over modulated wave is greater than 1. Next question. Which of the following is the advantage of is the disadvantage of FM over AM, right? What is the advantage of FM over AM? First option, larger bandwidth requirement. Larger bandwidth requirement. Second, larger noise. Third, higher modulation power. Four, low efficiency. So the question is, which of the following is the advantage of FM over M? FM is frequency modulated and AM is amplitude modulated. So the correct option is what? It requires larger bandwidth. So in case of frequency modulation, the bandwidth should be high, and that is the disadvantage of frequency modulated wave over amplitude modulated, right? So that's all about the problem solving. We'll meet you in the next class. Thank you.